For almost 60 years, the computer industry followed one simple rule. If you wanted a faster chip, you made everything smaller. Smaller transistors meant more power, better performance, and lower power consumption. This idea became known as Moore's Law, and for decades it worked. Every few years, chip makers managed to fit more transistors into the same space. Phones became faster, computers became more powerful, everything kept improving. But today, we're starting to reach a limit. Modern chips are now so incredibly small that some of their features are only a few atoms wide. Think about that for a second. We're talking about structures so tiny that you can't even imagine them with your eyes. And when electronics become that small, something strange starts happening. Electricity doesn't always stay where it's supposed to. Tiny electrical signals can actually leak through parts of the chip. That creates heat, it wastes energy, and it makes building even smaller chips much more difficult. So the big question became, if we can't keep making chips smaller, how do we keep making them faster? Well, Huawei may have found a very interesting answer. Instead of making everything smaller, Huawei decided to change the way the chip is built. Imagine building a house. Normally, if you need more space, you make the house wider. But what if you can't build any wider? The next option is simple. You build upward. That's very similar to what Huawei is doing. Instead of spreading everything across one flat chip, Huawei stacked part of the chip on top of another layer. It's almost like folding the chip into multiple levels. Those layers are then connected using incredibly tiny copper connections. These connections are unbelievably small. They're much thinner than a human hair. That allows different parts of the chip to communicate much quicker. Now, here's why this matters. Many people think transistors are the biggest problem inside modern processors, but that's no longer completely true. Today, one of the biggest challenges is actually the tiny wires connecting everything together. Imagine two people trying to talk across a football field. It takes longer. Now imagine they're standing right next to each other. The conversation becomes much faster. That's exactly what Huawei is trying to achieve. By stacking parts of the chip closer together, the electrical signals travel a much shorter distance. Shorter distance means less wasted energy. Less wasted energy means lower heat, and lower heat means the processor can keep running faster for longer. According to Huawei, this new design packs around 53% more transistors into the chip. At the same time, it improves power efficiency by around 41%, and performance also increases by about 13%. What's really surprising is that Huawei achieved all of this without moving to a smaller manufacturing process. That's a big deal. For years, the entire chip industry focused on making transistors smaller. Huawei is now showing another possible path. Instead of only shrinking chips, maybe the future is building them differently. This idea is often called three-dimensional chip design, or chip stacking. Instead of thinking in 2 dimensions, companies are starting to think in 3 dimensions. And Huawei isn't the only company exploring this idea. Many of the biggest chip makers are now looking at similar technologies because everyone knows one thing: we can't shrink transistors forever. Eventually, physics says no. So companies need new ideas if they want processors to keep getting better. Now, does this mean Huawei has completely replaced Moore's Law? Not exactly. Moore's Law helped shape the technology we enjoy today, but the industry is changing. Instead of relying only on smaller transistors, future improvements may come from smarter designs, better packaging, artificial intelligence, and stacking different chip layers together. In other words, the future of processors may not be about making them smaller, it may be about making them smarter. And if Huawei's new approach works as expected, this could be one of the biggest changes in chip design we've seen in many years. The race for faster processors is far from over. It's just taking a completely different direction. And honestly, that might be even more exciting than simply making everything smaller.